everyone, welcome back. In this video we're going to be talking about weathering, or the process involved in the formation of sediment. And we're going to cover sort of three main concepts here, including what sediment is, and then we'll talk about the two main types of weathering, including mechanical or physical weathering, as well as chemical weathering. So first let's talk a little bit about sediment and what that is. Sediment really is any kind of loose fragment of rock or minerals that have broken off of bedrock or rock that is intact. So it's broken off of that intact rock. It could also be mineral crystals that have precipitated out of solution or out of water, for example. It can also include shells or shell fragments. So sediment can include a number of different things. That's why when you go to the beach and you scoop up a bunch of sand, if you look really closely, that sand is actually made up of minerals like quartz and feldspar, probably, and also shells and shell fragments and all sorts of little things. So sediment involves any of those loose fragments of rock or minerals, any crystals that are precipitated out of water, and shells or shell fragments. So that's sort of a general definition of what sediment is. There's some examples here in the photographs of different types of sediment. On the far left in A here, you can see these people walking on sediment, loose gravel, some boulders there that you can see. So that sediment is unconsolidated. It's not intact. It's not forming a new sedimentary unit of rock. It's loose. In B here, you can see sort of a collection of seashells. There's a lens cap for a camera here for scale, so you can sort of get a sense for how large these seashells are. These are also considered sediment, even though maybe you don't think of shells as being sediment. In C, this is actually a picture from the Dead Sea. It's a very saline sea, so there's a lot of salt in the water. And here on these like iron posts or metal posts here, the salt is coming out of solution and sort of growing on these metal posts. And down in the lower image here, you can see this person is walking on bedrock. They're walking on, lithified rock that is compacted and cemented together, so it's solid. But right next to this person is sort of a bunch of unconsolidated sediment, and on top of that is soil. Okay, so that's what sediment is. Now let's talk about the different processes of weathering. So there are two types. There is mechanical, or sometimes referred to as physical weathering, and then there is chemical weathering. So we're first going to talk about mechanical or physical weathering. So first, let me give you a definition of what weathering is more generally. Weathering is just the breaking down of rock, whether it is mechanical or physical or by chemical processes. Weathering is just the breaking down of rock. Erosion, on the other hand, sometimes you'll hear the terms weathering and erosion put together. They're buddies, like they just appear all the time in geology together, but they are slightly different, and knowing that difference is important. So weathering, like I said, is the breaking down of rock. Erosion is the actual removal of that rock. Sometimes these things don't take place at the same time or in the same location. So even though we say weathering and erosion together all the time, in one place weathering might be taking place, and in another place just erosion might be taking place, or maybe they're taking place together. So weathering is the breaking down of rock. Erosion is the removal of that rock. Mechanical weathering, to be specific, is the breaking down of intact rock into unconnected clasts. So breaking it down into smaller pieces. That's really all it is. There are a few specific types of mechanical weathering, so I'm sort of getting more specific here. So we went from general weathering down to mechanical weathering, and now I'm specifying different types of mechanical weathering. So those types of mechanical weathering that I want to cover are jointing, wedging, thermal expansion, and animal activity. In the images that you see here on the screen, there's an outcrop, what we call an outcrop, right? We have rock that is outcropping at the surface. It's something that we can walk up and observe. So we have an outcrop of granite, and down here under the dotted line is fresh granite, So that's granite that hasn't been weathered. And above that dashed line is weathered granite. So this weathered granite in the top image here on the right has been weathered. And you can tell because it has sort of a rougher surface. There's sort of pockets in the surface of this rock where there weren't before, where there didn't used to be. And on the fresh surface, it's much more smooth and it doesn't have those pockets or those holes in the surface. So you can definitely tell the difference there between the weathered surface of that granite and the fresh surface of that granite. Okay, so let's talk about the different types of mechanical weathering. So the first type I want to talk about is jointing. Jointing is essentially the formation of natural cracks in the rock due to the removal of overburden. I've talked about overburden before. Overburden is essentially any rock or anything that was overlying the rock in question, the rock that we're talking about. So for example, let's say we're talking about this granite here in image B. That rock used to have other rock and sediment and all sorts of stuff on top of it, but it has since been removed or eroded away. So the removal of that overburden actually allows the pressure to decrease on that rock. And when the pressure decreases, the rock wants to relax a little bit. It naturally expands, and cracks will form in the surface. It's important to note that depending on what type of rock you're talking about, it's going to form joints differently. So in a sandstone, we have a couple of examples of sedimentary rocks here on the left in images A and C. Sedimentary rocks like that, like a sandstone, will tend to joint in a couple of different ways. One of the main ways is you'll get joints along bedding. So according to the principle of horizontality, sedimentary rocks like sandstone in this example are deposited horizontally. Sediments are laid down flat, and they're generally horizontal unless something structural happens to them, which we'll talk about in a later video. Between those layers of sediments, those are what we call bedding planes. And when a rock has the overburden removed and that pressure is released, those bedding planes can become more pronounced and they'll become more obvious. So that's a common place where you'll see jointing. You'll see parting between the planes of sediment or the bedding planes. In sedimentary rocks, you may also see vertical joints, like on a cliff face, for example, in image A here. This dark, shadowy patch, that is a vertical joint face where the rock, there used to be rock here, but it jointed and split apart and then was eroded away and probably fell into the water below. So those are some common types of joints that you would see in a sedimentary rock like a sandstone. On the other hand, intrusive rocks like granite tend to form a specific type of joint that we call exfoliation joints. And that basically just means that when you have that granite exposed at the surface or the overburden's removed above that granite, the joints sort of form in these concentric layers. So I like to think of it a lot like an onion. If these are eroded, you're sort of peeling the layers off and eroding them away. So I like to think of exfoliation joints as being like the layers of an onion. Exfoliation joints are like onions. They have layers. I hope that helps you remember it. Okay, so we're going to move on to another type of mechanical or physical weathering, and that is wedging. And there are lots of different ways that wedging can occur. First off, wedging generally just means you're sort of like shoving something into a crack and prying it apart. And like I said, there are a few ways that this can happen. You can get what we call frost wedging, which is when you have water that's filling cracks that already exist in the rock. And when water freezes, it expands. It's kind of an unusual feature of water. And you know this because ice cubes float in your glass of water, right? Ice cubes are less dense than the water itself. So water, again, when it freezes, it expands. And so if you have water sort of seeping into the cracks of a rock and then freezing, it's going to sort of wedge that rock open. And that's going to essentially cause mechanical weathering. And it's going to encourage that rock to break apart into smaller pieces. Another type of wedging that you might see is salt wedging. So this is when you have salt dissolved in water, NaCl floating around in water, and then it precipitates out of the water into cracks in a rock. And those growing crystals actually sort of wedge that rock apart and cause it to separate. You can also get what we call root wedging. It's hard to say, but we can also get root wedging, which is when you have plants that they're trying to find water, they're trying to survive, so their roots actually sort of creep down into the cracks in a rock, and they can actually pry the rock apart or wedge it apart. So that's another type of wedging that we might see. And again, oftentimes the result of this is that rock eventually falls away, sort of in this picture here. You see a gentleman standing next to a tree that is sort of pushing its roots down into this joint or this fracture here. And then the rock is eventually falling away or eroding away. Okay, the next type of mechanical weathering I want to talk about is thermal expansion. This can result in jointing, similar to what we spoke about earlier where you're removing the overburden, but this is a different process. So this is thermal expansion. So you're applying heat to the rock and you're causing that rock to expand slightly. Then the rock cools back down and it will shrink and fracture. And this can be caused by a few different things. Some extreme circumstances might be very hot forest fires. They can heat the nearest bedrock. For example, forest fires in the Sierra Nevada, for example, might cause thermal expansion of the granodiorite in that area. But even something as it might seem as minute as the daily heating of the sun. So a rock getting warmed up by the sun during the day and then cooling down at night. That's happening every single day and night, and that can cause those joints to form, and that's what we call thermal expansion. So that's another cause of mechanical weathering. Okay, so the final type of mechanical weathering that I want to discuss is animal activity, and that includes human activity as well. So if you've ever had like a gopher in your backyard, you probably know exactly how much damage those little guys can do. They really can bust apart rock, and they can erode it away. They can remove it. There are all sorts of burrowing creatures that can cause erosion like this. Earthworms, too, are a great example. But probably the most distinct type of mechanical weathering happening today is done by us, by humans on Earth. We do things every day like dig out quarries or mines, dig out foundations, or, put in road beds, things like that. That all involves mechanically weathering the surface of the earth. And in fact, humans move 24 times more material on Earth than rivers move sediment to the oceans. So I think that really goes to show all of the mechanical weathering that we're doing as a species is far beyond what would naturally be taking place if we weren't here. All right, so now I want to talk about chemical weathering. Chemical weathering is a different type of weathering. It's different from mechanical weathering. It's essentially chemical reactions that are taking place that alter or destroy minerals when rocks come in contact with water or the air. That's generally speaking what's going on when you have chemical weathering. There are three main types of chemical weathering that we're going to cover in this class, including dissolution, hydrolysis, and oxidation. So with dissolution, you essentially have a rock made of minerals that's being exposed to water, and those minerals are being dissolved into the water. An example of this that you've already been exposed to is calcite. When it's exposed to acidic water, it will yield calcium ions and carbonate ions. So calcite we know is CaCO3, it's calcium carbonate, right? But if you expose it to acidic water, that breaks up into the calcium plus, the Ca plus ion, and the CO3 2 plus ion. That's all that's happening is you're breaking those ionic bonds and you're putting them into solution. You're putting them into water. This also releases the CO2 gas, which is why when you drop acid on a calcite mineral, it bubbles, it produces gas. So that's an example of dissolution. It's really just breaking ionic bonds and putting those molecules into the water. And if we're talking about erosion and removing those ions, this happens really frequently. So you can dissolve the surface, parts of the surface of a rock. We looked at the picture of the weathered granite earlier, and there were all those like holes in the surface, and that's from the minerals actually being removed or eroded away. So again, sort of that slight difference between weathering and erosion. Okay, so one thing I want to highlight here when we're talking about dissolution is some real-world examples. If you've ever gone to a graveyard or if you've ever seen tombstones, there's some very popular stones that are used for headstones, including granite and marble. Those are two very common materials used for headstones. However, if you want your headstone to last, you're better off selecting granite or some sort of igneous rock, because marble actually dissolves in acidic solutions, like we just talked about. So calcite makes up marble. Calcite can be dissolved by acidic solutions like acid rain. So if you have a headstone that's made out of marble, eventually it's going to dissolve, like this example right here. This is a marble headstone that has been dissolved by acid rain over time. So you're better off going with something like a granite or a granite diorite. And while they are so beautiful, you may want to rethink your marble countertop. Marble countertops, they're essentially, marble is metamorphosed limestone. And again, it's made out of calcite, and calcite can be dissolved by anything acidic. So you don't want to get lemon juice on your marble countertop or tomato juice. Even tomatoes are acidic. So you want to be very careful about what you expose your marble countertop to, because you can get what we call etching in your marble countertop, like this image right here. You can see where someone set a glass of something or a can of something with some acidic solution dripping down the side, and it etched the top of their marble countertop. So again, you want to be very careful about what materials you're using in your life and also in your death. Okay, so the last type of chemical weathering I want to discuss is called hydrolysis. And I really like the end of this word. Lysis in Greek actually means to loosen. Thought that was pretty interesting. So hydrolysis is when you have water reacting chemically with minerals to break them down and form new minerals. So this is really, really common. And a very, very common example of this is when you have potassium feldspar and it reacts with acidic water to produce a mineral called kaolinite. Kaolinite is a clay mineral, and you frequently find it in makeup products and like face masks and things like that. But yeah, so this is an example of hydrolysis where you're taking potassium feldspar, acidic water, and you're getting a clay mineral called kaolinite. In fact, oftentimes the products of hydrolysis reactions are clay minerals. Minerals that react in hydrolysis reactions include olivine, pyroxene, amphibole, micas like muscovite and biotite. Those all will eventually weather into a clay mineral. So you can imagine that over a long period of time, our granites are eventually just going to turn into clay. But it takes a very, very long time for that to happen. Okay, the last chemical weathering process I want to talk about is oxidation, and this is one of the most common and one of the easiest to spot. Oxidation is essentially when an element loses electrons, and it often involves exposure to oxygen. That's why we call it oxidation. So an example would be the rusting of iron. And iron is in many, many minerals. Many of our quote-unquote ferromagnesian minerals that we've been talking about, olivine, pyroxene, amphibole, biotite. Oxidation means exposing those to oxygen and rusting the iron in those minerals. And you can see that happening in the picture here on the left. We have a granite being exposed to oxygen, so the outer layer of this granite is experiencing oxidation, and so it's turning this red, rusty color. Very simply stated, that's what oxidation is. It happens in all kinds of rocks, and it's this transformation of ferromagnesian minerals into oxidized iron. Alright, so before I wrap this video up, I really wanted to make a quick little addendum or edit to this video, just so I could sort of pull everything that we've talked about together. In the beginning of the video, we talked about sediment, which again are loose fragments of rock or minerals or shells, bits of shells, but also crystals that have been precipitated out of water. In the last segment, we talked about chemical weathering, which a lot of times involves the dissolution or dissolving of minerals, right? So those minerals, salt is a great example. If you take salt and put it in water, it will most likely dissolve depending on the temperature of the water. That salt, when those temperatures change or the environment changes, it will precipitate back out. It will form crystals again. So it will go from being a part of the solution, being a part of the water, to being precipitated out of the water. So remember this example of the Dead Sea where we have that salt being precipitated out of the water. So I just wanted to bring it full circle. You have minerals that can be chemically weathered away and then eventually deposited as sediment somewhere else. So that's how you go from the weathering and erosion of those minerals back to the sediment process, or back to the formation of sediment. So again, in this video we were talking about the idea of weathering rocks, or the process of forming sediment. Again, these processes take place over long periods of time. Sometimes, in the case of your marble countertop, that's a pretty quick reaction actually. But generally speaking, these take place over a long period of time. We talked about what sediment is exactly, just to get sort of an idea of what sediment is in our minds. And then we discussed the different processes of mechanical weathering and chemical weathering. I hope this was helpful for you understanding those processes of weathering, and I look forward to seeing you in the next video.